Okay, for first demo, I will show you the example of if-else decision structure. Okay, so based on this slide, so I will show you the demo for this one. Okay, so I will follow the step. Okay. Right, so I already set up the scene. So I put two bunnies, okay, bunnies 1 and bunny 2, and also a cake. So based on the step, first we need to set a variable for cake width, okay, because we want to make comparison for the cake width. Okay, so we set a variable. Okay, value type is decimal, so name is cake width. Okay, initializer we put 0 and then we click OK. So for the cake width, okay, because we want to get the real cake width from the properties, so the initialized value here, so we will change to the function of cake width. Okay, this cake get width, okay, from the function. So we put here. So meaning that it will read whatever size of the cake width from the cake width properties. Okay. Alright, so now we start with the if-else decision structure. So we select or we drag the if block. Okay, so we drag if block. Okay, and then we choose a condition is true. Okay, so we select the condition. Okay, so we select the condition. So the condition is decimal number. Okay, so we want to make comparison less than 1.0. Okay, width is less than 1.0, so we choose the first relational operator less than. Okay, so because we have two values, okay, the first value is cake width, we will compare cake width. Okay, less than, okay, we will choose the value of decimal, which is 1.0. So this is the step. Okay, so this is the condition. Okay, when if the cake width is less than 1.0 is true, so what will happen? Okay. So the first decision, okay, if the condition is true, so bunny 2, okay, bunny 2 will move to cake, and then 1.0. So this is the first statement. Okay, if the cake width is less than 1.0 is true, so the bunny 2 will move toward the to the cake. And then else, meaning that if this statement is false, okay, so do together, bunny 2 move toward to cake, okay, 1.0. Then second is bunny 1 also move toward cake, okay, 1.0. So this example of if-else decision structure. It's a simple structure. Okay, so you must remember first you need to declare variable of the comparison variable or the comparison value. Okay, and then you drag the if block. Okay, and then you choose the relational operators here. Okay, so relational, we have several type of relational, so you choose whatever that's suitable with your condition. Okay, and then you select the statement. Okay, so we will try to run here. So I will restart again. So it shows that the bunny 2, this is bunny 2, will move toward to cake. Okay, because the cake width is less than 1.0. So I show you the cake width. So this is the cake properties. So the width of a cake is 0.6. Okay, so that's why when we run, okay, bunny 2 will move toward to cake. Yeah. Right, so this example. So what if we change a bit of the condition? Okay, we want to make sure that the condition is false. Okay, so meaning that we need to set the value. Maybe I will change the value of this comparison value with relational gate width. Okay, so because our gate width is 0.6, so I want to make the value is 0.5. Okay, so if the gate width is less than 0.5, okay, it's true. Okay, so now the statement is actually false because our gate width is 0.6, so it will run, okay, the else statement below. Okay, so we look at the result. So we start again. So both bunnies will go to the cake. Okay, because the statement is false. So this is how you create the if else decision structure in Alice tree. Okay, this is just example. So the next demo I will show you another example based on the type of decision. Okay, now I will show you the demo for the decision types in Alice tree. So we have 4 types: single alternative decision, dual alternative decision, multi-alternative linear decision, multi-alternative non-linear or nested if decision. Okay, so we will start with the first one, which is a single alternative decision. So in lecture I already explained to you what is a single alternative decision. Okay, so I will show you the demo for this single alternative decision in Alice tree. So this is example. So actually I take the same example as previous first example. So I already declare a variable for the cake width. So single alternative decision used when the task performed only when particular condition is true. Okay, so if the condition is false, then no processing will take place and the if statement will be passed. Okay, so after we declare the variable for the cake width, okay, we drag the if block, okay, and then the condition is true. So we put the condition, okay, by choosing the relational operator, which is this, the first one, here relational decimal number. Okay, so we choose the first relational operator, which is smaller than. Okay, so the first value is cake width, okay, smaller than 1.0. So this is the condition. And then because this is a single alternative, so meaning that we only has one statement, okay, for the condition. Okay, so only one decision. Okay, so what happens if the cake width is less than 1.0? So the decision or the statement will be the bunny 2 will move toward to this cake. Okay, move toward to this cake amount 1.0. Okay, so this is the single alternative decision. Okay, only one statement here. So we click run. So bunny 2 will move toward to cake. So I restart again. So bunny 2 will move toward cake. Okay, because the condition, okay, is cake width is less than 1.0. So what happened? The bunny 2 will move toward to this cake. Okay, so this is the first example. Okay, so single alternative decisions. Okay, other than that, we also have single alternative with many processes. Okay, single alternative with many processes, so meaning that under true condition, so we can have different kind of processes. Okay, so this is the first process, which is the bunny 2 will move toward to this gate. So we can add another process or another procedure under the same condition, which is the true. So based on the example in the slide, so bunny 2 will jump. Okay, so there are two processes here. The first process, bunny 2 will move toward to the gate, and next bunny 2 will jump. So meaning that we need to create a new user-defined method for bunny, which is jump. So I already created the jump procedure. Okay, so this is the jump procedure. Okay, so I click bunny 2. choose bunny 2, and then I select bunny to jump. Okay, so we will try, or we will test the result. So this is what will happen. Okay, I restart again. Okay, move toward to the cake, and after that bunny 2 will jump. Okay, move toward to the cake and jump. So this is the example of the first decision, okay, which is single alternative decision. Okay, now for dual alternative decision, I will show you the demo. So dual alternative means when a choice is made between two alternative paths. Okay, there will be true decision or false decision. So this is the example. So I will show you this coding. Okay, so I already create the variable and also the condition. So what will happen if the cake width is less than 1.0? So both the condition are fulfilled, okay, for the true statement and also for the false statement. Okay, so for true statement, okay, the bunny 2 will move toward the cake 1.0, and then for the false statement, okay, so we add two together block, and then bunny 2 move toward to cake 1.0, and second is bunny 1 move toward this cake 1.0. Okay, so this is an example of dual alternative decision. Okay, so for one statement we only have one process. Okay, okay, so we will run the result. Okay, so we start. Okay, because the condition is true, so bunny 2 will move toward to cake. Okay, and then we also have dual alternative with many processes. They will execute multiple lines for any decision. So this example, so I will show you this one. Okay, so bunny 2, okay, first statement for true is bunny 2 move toward to this cake. So I will add another process. Okay, which is bunny 2 will jump. Okay, and then for else statement also I will add another process. So I add do together inside the else statement, and then bunny 2 jump. Okay, bunny 1 also jump. Okay, so this example of dual alternative with many processes. So I run. So start again. So bunny 2 move toward the cake, and also it will jump. It will jump again because we have two processes here: move toward and also jump. Okay, and then this is the false statement. I will show you for the false statement what will happen if this condition is false. So I change a bit of the condition. Okay, less than 0.5. Okay, I make the cake width is less than 0.5, so make sure that we can run the false statement of below. Okay, so again, alright, so both bunny we move toward to the cake, and after that both bunny will jump. Okay, because the condition here is false, so that's why it will go to the else statement. Okay, so this is an example of dual alternative decision. Okay, next is multi-alternatives linear decision. Okay, so this is the diagram or the flowchart for linear decision. So this form is called linear because each else immediately follow the if condition. Okay, so meaning that if your decision is false, so you need to test another if. Okay, so for multi-alternative linear decision, we need to add more if else block, okay, inside else, okay, for the next decision. Okay, so I will follow this example, okay, for multi-alternative decision. Okay, so this is a typo, it's not a dual alternative. Okay, this is actually multi-alternative. Okay, so multi-alternative decision example. Okay, so I show you in Alice. So we already create the code, okay, part of the coding. Okay, so for the true decision, so I have two processes here. So bunny 2 will move toward the cake, and second process bunny 2 will jump. Okay, so for multi-alternative decision, okay, we need to add, okay, another if statement inside else. Okay, so we drag if, okay, inside under else. Okay, so here we will create another condition. Okay, so for example, we choose this condition. Okay, if both, okay, true and, yeah, this one, yeah. Okay, so we choose this one, and both what conditions and with another conditions, yeah, so true. Okay, so for the first one, the cake width, okay, if the cake width is larger than, okay, cake width is larger than 1.0 and the cake width, okay, less than, okay, cake width less than 1.5, so we need to create 1.5. Okay, so this is the condition. Okay, so what will happen? Okay, so we insert the two together. So bunny 2, okay, will move toward to the cake. Okay, 1.0, and bunny 1 also will move toward to the cake. Okay, 1.0, and then else. Okay, so another do together. So bunny 1 will sit. Okay, bunny 2 also will sit. So this is the example of dual alternative. Okay, so for dual alternative decision, meaning that under else you need to add another if statement. Okay, so this is the condition. Okay, if both cake width is larger than 1.0, okay, larger or equal to 1.0, and cake width is less than 1.5 is true, so we will return to this process. So we will test the results. Okay, again. So based on this result, it shows that the condition is false. Okay, because it jumps to the else process or the else statement. Okay, both bunnies will sit. Yeah. So this is example for for multi-alternative decision. Okay, for the last category is multi-alternative or non-linear or nested if decision. Okay, so this multi-alternative non-linear, also known as nested if, so occurs when a number of different conditions need to be satisfied, okay, before a particular action can be occur. Okay, so this is the flow chart for the nested if decision. Okay, so we need to add more if else block, okay, inside if. Okay, so for the nested decision. So this example, so I will show you the demo for this example by using Alice. Okay, so this is the coding that I already create. Okay, so if the cake width is larger than 1.0, so we will add another if block here, and then before that, because we want to compare between different variable, a new variable, so that's why we need to create a variable, okay, for cake table height. Okay, so we need to create a variable, so we drag here. Okay, decimal number, so the name is cake table height. Okay, and then click OK. And then so based on this one, what is the cake table height? So cake table height is actually the combination of coffee table or table height plus with the cake height. Okay, meaning that we need to replace this initialized value with the function, okay, which is the table. Here I choose the dining table, so the dining table get height, okay, plus, okay, so we choose a math. Okay, so dining table get height plus, and so we can choose any value here because this value also will be replaced with the function of gate height. So 0.0 will be replaced by gate height. Oops, sorry. So again, okay, so gate height. Okay, so now we already create the variable for cake table height. Okay, so we proceed with another if statement, okay, below the variable. So we drag the if block, okay, under the variable, okay, true. Okay, so here, okay, if cake table height is larger or equal to this bunny get height is true. Okay, larger or equal, okay, cake table height larger or equal to, okay, so we replace this value 0.0 with the bunny 1 get height. Okay, so if cake table height is larger or equal to the bunny 1 get height, so what will happen? Okay, so bunny will move toward cake, bunny 1 will jump. Okay, so bunny 1 will move toward cake, and bunny 1 will jump. Okay, so multiprocesses, and then else, okay, bunny 2 move toward cake, so I meant bunny 2 jump. Okay, so bunny 2, okay, move toward cake, and then bunny 2 also jump. So for else both bunny will sit. Okay, so by using the do together, okay, so bunny 2 sit, bunny 1 also sit. Okay, so this is the example of multi-alternative non-linear or nested if decision. Okay, so I will click run to see the results. Okay, again, so based on the result, it shows that the first condition is actually false. Okay, that's why it just jump to the else statement. Okay, so both bunny will sit. Okay, so if we want to see the first statement, which is the true statement, yeah, so we need to change the condition, or we need to change the cake width. For example, I change the condition, okay, because your cake width is 0.6, okay, 0.6. Okay, so I choose larger than is true, 0.6. Okay, so the cake width is larger than 0.5. Okay, so it will be true, right? Because the cake width is 0.6. So 0.6 is larger than 0.5. So you will go to this true statement. But you will test another if statement, okay, comparing with the cake table height, okay, with the bunny 1 height. Okay, so I will run. So again, okay, so this is a bunny 2. Okay, so meaning that the if statement here inside the first if is actually false, okay, because it will jump to the else statement. Okay, so bunny 2 will move toward cake, okay, and then bunny 2 will jump, okay, meaning that the cake table height is not larger than this bunny get height. Okay, so bunny 1 height is actually larger than table height. Okay. So I show you the bunny 1. So bunny 1 height is 0.8. Okay, 0.8. Okay, table is 0.4. Okay, plus with cake 0.2, so it's around 0.6 something. So that's why bunny 1 still higher than table and cake. Okay, so that's why this if statement is actually false, so that's why it goes to the else process here. Okay, so this example for our last category of decision, okay, which is multi, alternative, non-linear or nested if decision.